Assalamu alaikum everyone. Welcome back to my channel. Hope you're all fine. And today we are starting the full length papers and we will attempt the Computer Science 9618 paper 3 May-June 2023. And I'll be attempting the questions and will explain the key aspects of meeting the standardized need of the right answers. So let's start with the question number 1. Now in the question number 1, the numbers are stored in computers using floating point representation with 10 bits for mantissa and 6 bits for the exponent, and the 2's complement form for both the mantissa and the exponent. Now this is the question, and this is the number, the normalized floating point representation of the following binary number. This is the binary number, and we have to represent this number into the mantissa and the exponent part. All right, so what we will do, let's start. So first we'll write the working area 0 1 0 1 0 1 0 dot 1 1 1. So this is the number, and with the number we will, the decimal in this number we will move in the first 2 bits, and that is 0 and 1. This is the rule of dealing with the real numbers, that we have to take the decimal to its ideal location, and that is the initial first 2 bits, 0 and 1. So we'll count how many number it has moved. We have moved 1 2 3 4 5 6. So we have moved 6 places, 0.101 0 1 0 1 1 1 into 2 raised to power 6. So this is how we calculated the exponent, by placing the decimal on its right place, right position. And you know that 6, when we convert it into binary, it is 0 1 1 0. All right, so this is 6, and the number, this is the exponent part, and the mantissa part we can write 0 1 0 1 0 1 0 1 1 1. All right, so now we have to fill it in the given area of the exponent, and the rule to put the exponent that we have just calculated for the 6, we will start filling it from right to left. So this is 0 1 1 0, and the remaining will be filled by 0. And the rule to fill the mantissa in its given part is from left to right. So from left to right. So this 0 1 0 1 0 1. So we have 2 2 4 0 1 0 1 0 1, and then 0 and 1 1 1. So this is the answer of this question, this part. Now in the B part, what it says in the B part, describe the reason why the normalized form of the following number, binary number, cannot be represented accurately using this system. Now what is the reason that we cannot place this number? Like if this number has to be stored, the reason that when we will take this number in the same way when this number will reach here, so what the number will become, you can see the number will become 0 1 0 1 0, then 1 1 1 1 1 0 0 1. So this is the mantissa part. Okay, this is not the exponent part. We are not going to calculate exponent here, because the question says describe. Describe means you have to explain that this decimal, when it moves, describe the reason why the normalized form of the following, and the term normalize here means the first 2 digit must not be 0 0 or 1 1. Okay, so describe the reason why the normalized form of the following binary number cannot be represented accurately using this system. Now if we read the digits 1 2 3 4 5 6 7 8 9 10 11 12 13, So there are 13 digits now here for the mantissa, and the space given to us is 1 2 3 4 5 6 7 8 9 10. So the space is 10 and the digits are 13. So this is the issue that we have to write over here, that the we can say that the mantissa part, the mantissa part of this number, what will happen to it? Will not be completely stored. Why? Because there are 10 places or bits available. Okay, this is one point. So we can have this now. Actually, we have written here 2 points. One is that the mantissa part of this number will not be completely stored, and the second point is 10 places are available to us, and it means the last 3 digits will be dropped. So will not be able to that can cause precision error. So the number will not be as precise as we need. So this is the answer of this part. Okay, I'm sure it is clear. Okay ji. Now the second question, how records are organized and accessed in sequential file. Sequential file where the data is arranged in order. Okay, so the records are organized, what we'll say, records are always in a sequence. Records are always in a sequence in sequential file sequence, or we can also call it they are in order. Okay, and then this order is based on a key field. This is actually created by a key field. Okay, so the records can be accessed in the order of this key field. Okay, so these are the points that how we can access. I have written 3 points, and so we'll keep searching or reading record until reach to the one we are looking for. Okay, So this is how we do this. Now the next part is a hashing algorithm is used to calculate storage location for records in a random access file. The algorithm calculate hash values using the function modulus 5. The function modulus 5 gives the remainder after integer division. For example, 3003 modulus 5 gives 3. So the record key 303 gives a hash value of 3. Okay, now what is the key hash value for 1029? So basically for this what we have to do, 1029 and divided by, actually modulus 5 means with 5. So when we divide it with 5, 29 and then 5, so the remainder is 4. So 4 is the hash value. Basically modulus give us the remainder. Okay. Okay. So in the same way, when we divide 7630 modulus 5 give us 0. So the remainder is 0 here. Okay. Now coming to the question number 3. Now this is the syntax diagram. The digits are 0 to 9 and the letters are A, C, E and all the letters given over here. Now this is the diagram, the syntax diagram that we'll be following. And in this diagram, the variable, it is a letter or can be many letters, or it can be many letters and a digit. Okay. So this diagram tells us that it can be, the arrow back means it can be many letters. So when we use this arrow back, so from here many letters, and it can be 1 letter, 2 letter, 3 letters. So and after the letter it can be only the letter, and this arrow means then the option without using the digit, the letter is enough for the variable. Or in other case you can have letter and then you can have a digit. Okay, but in digits you don't have loop. Okay, so based on this rule, so we can see that this diagram is telling us that the variable must start with a letter, and here you can see it is starting with digit, so it is invalid. Reason, how many marks is that? The variable must start with a letter. Alright, so this is the reason, and this is a valid because the variable is starting with a letter or letters. Okay, so this is how we attempt it. Then comes the next part, and that is the word contain one or more letters. Complete the BNF, the Beckes-Nor form for word, and use this to complete the BNF for variable. So word is defined as, now word contains one or more letters. Okay, so we will write it that word can be defined as a letter, or it can be can contain one or more letters. Okay, or it can be, so this is actually called recursions. it can be letter, and again. So we can recursively define that word. Let word can be defined as created by, it contains one letter or more letter. So we use that. And variable can be defined as, so now we can see this variable can be defined as letter digits. So we can call it, variable can be defined at, how can we do this, that variable can be so we can have as many words, so we can call it, it can be a word, variable can be a word, or, and then it has a digit, all right, digit. Variable can be a word or a digit, single word, or it can be we can also again use the recursively define. It can be word, it can be word or digit. Okay, so it can only be a word or it can be a word with a digit. So we are not using recursion, although recursion is here in the word, so it is part of it, but we are saying that the variable can be a word, which means it can be a letter or it can be letter and word, as many letters, and it can be as many letters with a digit. So this is how we will define the B. The vehicle registration must begin with 2 letters and be followed by 1, 2 or 3 digits. Must begin with 2 letters. Valid letters and digits are shown in the syntax diagrams on page 4. So letters, we need to only use the letter which are given here, A, C, E, G, I, K, M, O. So only these letters can be used. And digits, these are all digits 0 to 9. So the question says, state an example of valid vehicle registration. So begins with 2 letters. So we can have A, C, followed by 1, 2 or 3 digits. So you can see A is here, A is here, C is here. So we are not giving any letter which is not mentioned here, A and C, and then the digit, it says 1, 2 or 3 digits. So we can have 2, 4. So this is a valid example. Draw syntax diagram for a vehicle registration. For the same, we have to now draw the diagram, syntax diagram. Vehicle registration. The syntax diagram now, it always starts with an arrow, and here we'll say it is for the vehicle registration. Okay, so vehicle registration, what it has, begin with 2 letters. Okay, so we have two letters, and then what it says, and followed by 1, 2 or 3 digits. So we have digit, 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 and now we have a choice in it. 1 means the arrow, when it goes to the end, it means only with 1, all right, or 2. So 1 and this is the 2 and this is 3. This is how the diagram, the syntax diagram for this question is developed. So it means now you can see begins with 2 letters followed by 1, 2 or 3. So we have a choice in 1, 2 or 3. So that this choice is 1, 2 or 3. And the letters, there's no choice. So we have 2 letters here. Okay. Now the next question. Encapsulation, this is related with the OOP. Sorry. So in the OOP, first one is the encapsulation. Encapsulation is the method used to return the value, the process of putting data and method together as a single unit. So this is the encapsulation. Getters, method used to update the values of a property, allow methods to be redefined for derived class, enable, method used to return the value of a property. So when this is actually the valid one. Polymorphism allows method to be redefined for derived class. So this is the polymorphism. And setter, method used to update the value of a property. So this is the setter. All right. Question is that encryption is used to scramble data to make it meaningless if intercepted. This is the encryption. All right. So in this question it says describe the purpose of quantum cryptography. Quantum cryptography you all must have studied, and you know that quantum cryptography has more secure way of transferring the key. So what is the advantage? Describe the purpose of quantum cryptography. The purpose, we can say that to produce unbreakable encryption system, so which is not easy to crack by the hackers because it uses the principle of quantum mechanics. It uses means the use of the photon. You know, photon has various oscillations, and that helps to create more than 2 states of zeros and ones that you must have studied. And if anything is intercepted and if there is any change in between, the both hand will easily come to know that the data is being intercepted or is being corrupted. All right. So it has more stronger way of the encryptions, or the more stronger way of transferring the keys. Explain the difference between symmetric and asymmetric cryptography when encrypting and decrypting. So symmetric, it's very simple question. Symmetric uses same keys to encode and decode, and asymmetric uses two keys public and private. Public key is usually published and used to encrypt the data. The private key is kept private and used to decrypt the data. All right. The pseudocode statement to declare the composite data type T appointments to hold data about patients of a dental clinic. It will include, now here, the composite data type. Okay, and its name is T appointments. And we have to write the the pseudocode. So we'll write type T appointments. And it has these data. Declare name, first name and last name, so it is string. You must remember that the composite data type, they are this is the user defined data type which is created by referring to the built-in data type. All right. So we'll be using the built-in, and which are the built-in data types? The integer, real, char, string, data, and boolean. These are the built-in data type. Declare date of birth of date, declare telephone number, it can be string. The whole numbers are actually starting from 0, 1, 2, 3, that's why it's better to have it string if you put dash and something like that. So declare date of last appointment, and then declare date of next appointment. All treatments are complete. Boolean, students, they usually not close the type. It is important, you must close it. Okay, so this is you can see this question by writing only the types. You can have this question done very easily. Okay, now in the next question, in the B part, what it says, this pseudocode algorithm reads dental records stored in a random file using the user defined data type T appointments and print the content of the file one record at a time. Complete the file handling pseudocode. But now in this file handling, we are dealing with the random number, random files. Okay, so initial lines read declare dental record array of T appointments, dental file, string, count, integer, file name. Output the file, dental file contain these records. Now open file, from here we will start. Open file, and the file is dental file. open file, dental file for random. This is the keyword that makes it different from the simple file handling. And then open file for random, and you know, in this question what we are doing, a record stored in the random file using the and print the content of the file one record at a time. So we will have, you can see we are dealing with a count, so we initialize the count here. Repeat seek dental file count, and then what we will write, this is important part of the random get. So we write, this is the key command, get record, and then get record for the dental file. So it will retrieve the record from the dental file and will place it in the dental record array. Because it is the main aspect of this code. Count is referring to the indexes, and then we are outputting this, and then count is count plus 1, and then repeat after repeat we have until. Actually this will keep happening until end of file, because we are using repeat until so it is end of file. If it was while loop, then it would be while not end of file. So you know the repeat until is a false based loop. So in the last we'll close file, and then we will mention the file name which is kept in the data. Sorry, dental, it is not data. So this is the complete the fill in the blanks. Okay. State 2 examples of where it would be appropriate to use packet switching. It's very simple. Packet switching, you know, the data packets, all the data packets, they follow a different paths. So the packets, they are traveling on a different routes, and then they reach to the destination, and then they reach in different order, and then they have to rearrange themselves. So what we will write over here, examples where we can use packet switching is we are not in hurry, so packet switching it can be used to send data files, okay, on how many, on networks, on internet, okay, where so we can send it where speed is not an issue. Speed means that the packets, they must reach all together in the right order. That is not required. That is not an issue. And the next point is that we can use it for The second is that what other point? When it is not needed to use all the bandwidth, okay, you don't need all the bandwidth of the transmission channel. We don't need all the bandwidth to be consumed. Okay. Four differences between the circuit switching and the packet switching. It's very simple. You can do it. Packet switching is most commonly, the differences. Circuit switching, it is used for the dedicated lines. A path is being established between sender and receiver, and all packets, they travel all together, while in the packet switching the data will travel in different via different routes. So you can do it. This is a simple question. Okay, I'm leaving it. Describe the use of pipelining in the reduced instruction set computers. There are two philosophies that are being followed for the processor architecture. One is the RISC and the other one is the CISC. So it says the use of the pipelining. Pipelining means the parallel processing. Okay. So what is the use of pipelining in RISC? It let us several instructions to be processed simultaneously. So we can process several instructions all together. Okay. So it means it will, in this way, it will increase the throughput. It will increase the throughput of the processor when multiple instructions can be executed at once. Okay. So now see this question, B part. The instruction fetch, there are 5 stages: instruction fetch, instruction decode, operand fetch, instruction execute, write back result. Each stage is carried out using a different register. When pipelining is used, complete the table to show how a program consisting of 6 instructions would be completed using pipelining. So how will we do this? We can instruction fetch. Let's say we have instruction A is fetched, and then what will happen when instruction A is sent to stage 2, B will be fetched, and when instruction A will be sent to stage 3, the B will be in the second stage and C will be fetched, and when A will go to stage 4, B will be operand fetch and C will be instruction decode and another instruction, the instruction D. So we have 6 instructions. So D will come. Okay. So here when A will go to write back, the B will come to IE and the C will come to OF and D will come to ID, and another instruction E will be fetched. Okay. So 6 instructions. So likewise, now the B, when B is done over here, so what will happen? The B will come over here. So C will come over here, and D will come over here, E will come over here, F will come over here, and in the same way. So now the C will come over here, D will come over here, E, F, and then when D will come over here, E will come over here, F here, and then E, F, and then F. This is how the 1, 2, 3, 4, 5, 6 instructions, they are executed on each clock cycle with the help of the pipelining. Okay. So we are reaching till the in the last questions. Now the question number 9, and this question number 9 is about the K-map. It is related to the hardware chapter, and in the K-map, now this question is very important question, or this topic is very important. You should not miss it. And first of all, you mark the 1 part, 1, the question with the output 1. So because you will be writing the status of these ones only over here. So 1 has, now it has 0, 0, 0 and 0. So it means A, B, C, D all are not 1. 0 means not 1, and 1 means without any complement signs. So here 0, 0, 0, 1. So this means A naught, B naught, C naught, and 1 means without naught. All right. And then here we have 0, 0, 1, 0. So A naught, B naught, C, and D naught. And here we have 0, 0, 1, 1. A naught, B naught, C, and D. And here we have 0, 1, 1, 0. So this is A naught, B, C, and D naught. And here we have 0, 1, 1, 1. A naught, B, C, and D. All right. So these are the expression. These are the this is what we will derive from this table, and then the same is going to be written over here, and that is the sum of product, and I will write it while transferring. Be very careful so that there is no mistake. A, B, C naught plus A, B, C, D, A naught, B naught, C naught, D plus A, B, C, D, so A naught, B naught, C, and D naught, and then plus A, B, C, D, A naught and B naught, C and D's, and then we have A, B, C, D, so A naught and D naught, B and C is nothing, plus A naught, B naught. So this is the answer. So in the first we have all knots, in the second we have 3 knots, and then last D is off. In the third we have first, second knot, C is clear and D knot, and then we have first 2 clear, first 2 knot, and then C, D clear. First and last is knot, and B and C is clear, and first is knot, and B, C, D is not clear. This is 3-mark question, and now with the same we are going to fill this map. This is important. Now we have to be very careful. A naught, B naught, C naught, D. Now look here. This 0, 0 is actually A, B naught, and this is A naught, B. This is A, B. This is A and B naught, and this is C, D, C naught D naught. I'm just drawing it for your better understanding. C naught D naught. And this is C naught D. This is CD. This is C and D naught. Alright. Now with this you will get an easy understanding of it. Now first is A, B, C down all with not sign. So we will mark this as 1. And the second is, so this is done. Second is A naught, B naught, C and D. Only the D is left. So A naught, B naught, C naught and D. So this you can see A naught, B naught, C naught and D. Alright. So this is done. And A naught, B naught, C and D naught. A naught, B naught, C and D naught. So this one. Because A naught, B naught, C and D naught. Alright. So this is done. Then A naught, B naught, C and D. So this is failed. Alright. So we are done with these 4. And then A and D naught, B and C mein kuch we have nothing. A and only the first and last is on, and B and C has nothing. First and last is on, so it means this one. Alright. And this is done. Only the first is on. So this is on. Sometimes the students, they leave the other cells empty. Please don't leave it. Put 0. That shows that there is no more 1 over here. By filling this table, we get 2 marks. Okay. Now the second is to have the loops. For the loops, you should remember, just let me select a color. Okay. For the loops, we can make the loop of 2. We can make the loop of 4. Okay. We cannot make the loop of 3. Okay. So this is one loop. And you also remember that the loop can only be made by of the adjacent ones. Although their positions, they can be, there are different possibilities of their of calling them adjacent. For that you need to have a separate lesson on the K-map. I will try to make it as well. But now we have short of time, so we'll not go into that. Okay, so you can see this is the looping. So also for this you get 2 marks. Now we have to simplify. Now we have to simplify it. And how will we simplify it? Each group will be written separately. Now you can see this one. We will take one loop, that is A naught, B naught, C naught, D naught. Okay, this first one. And this is A naught, B naught, C naught, D. Second, and the third one is A naught, B naught, C and D. And the fourth one is A naught, B naught, C and D naught. What is the rule to attempt it is the complement is going to be cancelled with the other, like D naught is complement, D naught with D is cancelled, and D is, so this all is going to be removed. And likewise C naught, C and C, this is also removed. And then we have, now in these two we'll take out the common one. So the common is A naught and B naught. So this is the case with the one loop of 4 ones. Now coming to the second loop. For the second loop again we will take out the values. This one is A naught, B naught, C and D. A naught, B naught, C and D, this one. And then A naught, B naught, C and D naught, this one. And this is A naught, B and C and D. Be very careful. If with a single mistake the question, you will not be able to draw the right expression from it. And this last one is A naught B, A naught B, C and D naught. Alright. Now you can see here again, D is cancelling D naught, D is cancelling D naught, so this all is cancelled. And B is cancelling this B naught, and this also cancelled. So from here we derived the common A naught and C. So what we'll write? We'll write A naught B naught plus A naught C. So this is the solution or the answer of this D part. Now in the next, use Boolean algebra to give your answer to B, D in the simplest form. So we take this, and how it can be simplified, we can take the common A naught, and in between we have B naught plus C naught, sorry. This is the, we derive the common, and you can see this is how we solve it. Okay ji. So the question number 10, one category of the machine learning. So which category? We have the machine learning, we have the deep learning. Okay, or it can be the supervised learning, anything else. Okay, now this question is related with the AI. Calculate the path that takes the shortest time to travel from the begin node to the end node, and this is the begin node and this is the end node. So we have to find out the shortest path using the A star algorithm. Show your working in the table provided. First two rows have already been completed, so this is already done. Okay, so see how we'll do this. The A star algorithm, okay, in the A star algorithm we have we start with the begin, and you can see from the begin the cost from the start node is 0, so begin to begin is nothing, and the heuristic value is 12. So actually, so 0 plus 12 is 12. So from the begin, the joints, the node which are connected, A is connected, B is connected, C and D is connected. So from begin to A, the distance is 5. Cost from the start node from begin to A will cost 5, and then the heuristic value of the A is 8. So 5 plus 8 is 13. This is how this 13 is calculated. Okay. Now this A is done. Now we'll from begin to B. Okay. Cost, what is the cost? Cost is 6, and what is the heuristic value is 7. 6 and 7, 13. So it is also the same. Then the third, from begin to just a minute. From begin to C. So from begin to C, the cost is 5, and the heuristic is 7, and it is 12. All right. Now from begin to D, the cost is 4, and the heuristic is 11, so it is actually 15. So now from these we'll see which one is the shortest. G. So the shortest one we can see over here is the from begin to C. This one is the shortest. All right, this 12 is actually from begin to begin, so we'll not consider it. Okay, so we now the next point from begin to will move to C. We'll move to C. Just rub the others. Okay. Now we move to C. Now with the C, so from start node is now we have the C here. So from the C, which one is connected? Only G is connected. So from C to G, and from C to G, the cost from start node is 5 plus 2, 7. Okay. 5 plus 2 is 7, and the heuristic for the G is 5. So when it is 5, 7 plus 5 is 12. Okay. So this is 12. So it means now we don't have any other option. We have to move to, now the next one is that we move to G, because there was only one node connected, so we don't have any other option. Now we reach to G. Now with the G, we are gradually moving toward AND. From the G, AND is directly connected and F is connected, and then we can reach to G. So from the G, first we will see G to F. G to F. So from G to F, we need 5 plus 2, 7 plus 4. 5 to 7, 7 plus 4 is 11. And then the F heuristic is 1. So this becomes 12. Okay, this is 1. And the other is that from G to direct AND, you can see G to AND, 7, 5 plus 2 and plus 7. And this becomes 14. And from AND to AND is 0. There is no heuristic. So actually it is 14. Now if we see in the G both, which one is the shortest? G to F is shortest. So we'll calculate F here. Now we move toward the F. And now you can see F to AND. F to AND, again we need 5 plus 2 plus 4 plus 1. F to 5 plus 2 plus 4 plus 1. This becomes 7 and 8, 4, 12. And then AND to AND is 0. So 12. Now you can see the shortest is F. This is how we calculated it. Now if you see the shortest, if we see the shortest one, the first is that we start from the begin. So from the begin, the next one was 12, begin to C. So we move to C. From the C, then we move to G. From the G, we move to F, and from the F, we move to. So this is the final path. This is how we solve this A star algorithm. All right. Now I think this is the last question. Yes, this is the last question. Let's do it quickly. This is the ADT, and this the paper 3 always have the one last question that is related to the ADT. The pseudocode represents a Q abstract. This is Q ADT. The procedure for initialization and add new items. It is incomplete. Okay. So what we will do? Constant max length is 50. Front pointer, rear pointer, length Q. Initialization, front pointer is -1. So what is the next one? Definitely we initialize the pointer first. So rear pointer is also -1, and then we are going to initialize the length. Length is 0. Okay. If the length is less than what is the maximum length, this is the first thing that we need to check in the queue. And why we are checking this? To make sure that the queue can be executed in a circular, and this condition will take us to rotate the queue when it reaches to the last index. Okay, if this condition is met. If it is false, then we cannot turn back. Okay, so after this, rear pointer is this we will increment rear pointer +1, and then the rear pointer, rear maximum length, and rear pointer. This is the circular queue, and then we are going to add, because we are adding. So the queue, which is the array, and the rear pointer. You know, in the queue, the addition is always done on the rear pointer, the new item. So this is the new item, sorry. All right. Then the identifier array to store the content of the queue is the queue. It's very simple. Just you just put the variable name from here. It's very simple. I will not do this. Complete the given pseudocode. Explain the reason why a queue works better than a stack ADT. What is the reason? Queue, you know, especially in organizing the print jobs. You know, the print jobs, they are executed in the order in which they are sent. So that's why the queue is more better. Otherwise, in the stack, the first job will be done in the end. So that is not right. The printer queue will, so the job given first will be executed first. All right. And if it was stack, then the first job is done in, and sorry, because of I'm writing with the stylus, so I'm exceeding the limit of the area. So this is how we solve this paper. I'm sure you all have understood the key things in it. Thank you very much. Allah Hafiz.